Welcome to the fourth lecture of the course CSC 101, Introduction to Computing. Let us begin by the introductions of the class 5779. Let's go on and let's now do a review of the previous lecture, lecture number 3. So in lecture number 3, we spoke about the big O notation and we looked at several examples of big O notation. And if you had a specific algorithm, then how would you actually determine the big O? You would simply take the highest power of n. Next, we looked at some simple examples of order of n, then order of n squared, and order of n cube, iterative algorithms. We looked at how their complexities in time could be graphically represented as you varying n and the value of the algorithm, the time complexity is changing in terms of seconds. So this is here in terms of time. Next, we looked at the unsorted example from the previous lectures, and we saw whether it can be improved or not. Okay, so this was a linear search using an unordered list. And then what we saw is that if we somehow assumed that we could somehow get this into an ordered set, then we saw that this could be greatly improved, right? And we went through that algorithm and we saw that you could actually do a binary search. And the binary search, basically you start off in the middle. And if you compare this number with the number that you're searching for, and so if this number is smaller than the number you're searching for, you look in the top half, otherwise you look in the bottom half, and that's how you split up the list, the data set, into halves each time. So every time you're basically halving the entire list. And so as a result of that, we saw that the amount of time that you're going to take is going to be not linear in n, but it's actually going to be log of n, okay? And that's a significant improvement as n becomes very large. And so this is one of the objectives of computer science algorithms, is to be able to have good algorithms which can actually reduce the time complexity. One of the things which we haven't spoken about is space complexity. And that's also important, but we'll talk about that at a later stage in this course. So now I'm going to move forward and give you some more examples and try to also see how to actually understand those examples and how to try to be able to figure out whether the algorithms are working properly. And if you've actually implemented an algorithm, how to make sure that it's verified. And there's something, the concept of debugging. Okay, you might have heard of this, which basically means that if you've got an algorithm, you think that it works, but it may not necessarily work. And it probably, initially, it might give you the wrong results. Okay, so how does one make sure that the algorithm is actually working according to what you want it to work, what your objectives are, okay? So we'll do that by looking at several simple examples. And we'll start off by looking at one of the oldest algorithms, which is referred to as the Euclidean algorithm. And this was by Euclid, which was circa 300 BC. So you can imagine this is one of the oldest algorithms that one can think of, okay? And so I'm sure all of you have come across the term greatest common divisor, okay, or GCD for short, okay? So if you have a set of numbers, integers, then the GCD is the largest positive integer that divides each of the integers, okay? So for example, if you've got two integers, A and B, and you want to find the GCD, so let's say those two numbers are 8 and 16, okay? So the greatest common divisor would simply be 8 because 8 can be divided by 8 and 16 can also be divided by 8, okay? So it wouldn't be 4 because 4 can divide both 8 and 16, but it's not the largest integer, okay? So 8 would be the largest integer. So for 8 and 12, for example, the GCD would clearly be 4. It wouldn't be 8 because 12 can't be divided by 8, but 4 can divide both 8 and 12, right? So the question is, how would one find an algorithm for that, okay? So Euclid came up with an algorithm a long time ago, And this is there in your book, which is Brookshire and Brylow. Many of you have been asking for whether we have a book or not. I've already uploaded it, and this should be in your email as well. So this is uploaded in the book section in the LMS, and we're going to be referring to this book quite frequently. It's somewhat of a older version, 2015, but I'm still using that simply because an online version of it, a downloadable version of it, is easily available. The newer versions might be slightly improved, but it doesn't really matter as far as this course is concerned. A 2015 version of the book is perfectly fine. Okay, so you can download it and look at it and make marks on it and so on. So let's look at this example. Basically, the Euclidean algorithm says that we're going to find the common divisor of two positive integers in the following manner. Okay, the algorithm assumes that its input consists of two positive integers and proceeds to compute the GCD of these two values. Okay, so we're going to start by saying assign. So every algorithm will have a series of steps naturally. Okay, and there has to be some mechanism to stop the algorithm as well. These are things that we've already studied. So this algorithm says that assign m and n the value of the larger and the smaller of the two inputs. Okay. So for example, you have 8 and 12 are the two values. So it's saying that m should be the larger of the two values. So let's say that m is assigned 12 and n is assigned the number 8. Okay. Then the step 2 says divide m by n and call the remainder r. So we're going to divide 12 by 8 and we're going to call the remainder r. And so the remainder is clearly 4. The quotient is 1. And then it's going to say if r is not 0, then assign m the value of n. Okay, so clearly r is not 0 right now. So what we're going to do is going to assign m the value of n. Okay, so m now has the value of 8 and assign n the value of r. Okay, so the n is now going to get the remainder. So n is now going to become 4. And now return to step 2. So we're going to now do an iteration. So this was the first iteration, and now we're going to start the second iteration. Okay. Again, we're going to divide m by n. So now we're going to divide 8 by 4. Okay. We're going to assign r to be the remainder. So clearly the remainder is 0. The quotient is 2. Okay, the quotient here was 1. And then we're going to say if r is not 0. Now clearly here r is 0. So we're not going to do this step anymore. We're not going to do any further steps. What we're going to do is we're simply going to say the GCD is the value currently assigned to n. So the value currently assigned to n is 4. Okay, so this becomes the GCD. Okay, so the GCD is equal to 4. So it's a very simple algorithm, as you can see, and it performs iteratively, and there's a terminal condition. So, and you can look at this algorithm. It's on the Wikipedia, which is something that I'm going to refer to sometime once in a while. G.
Tariq Iqbal, sir, does this algorithm have like a mathematical definition, or is it just an algorithm to help you do this common divisor thing?
Okay, so when you say a mathematical definition, so the question is the algorithm very precise? Okay, sometimes you can have algorithms which are very vague and they can't really be implemented. Okay, a very good algorithm, a clear algorithm, a precise algorithm will be one which can actually be implemented in on a computer program. Okay, now if you look at this, the description right now is fairly high level, but this can be implemented on a computer. It has all the details necessary to be able to implement it. Okay, so we can say the algorithm is fine. It's perfectly fine. Whether you can implement it or not, that depends on you. Okay, so if you know a good programming language, you should be able to implement it in a very simple way. Okay, so I hope that answers your question, Tariq.
All right, sir.
Okay, now the next question is, what do you think is the time complexity of this algorithm? Okay. And this might be a little tough question. If you remember the different time complexities we looked at, we saw that there was an order of n, or it could be order of n squared, n cubed, n log n, or order of log n. Okay, so the first question is, what is n in this particular case? Okay, so when we say time complexity, we need to have some parameter n. So what is n over here? Any thoughts? People from
Sir,
5779. G.
Adnan Shah.
G Adnan.
It might be the steps we are performing.
It might be the steps. So Adnan thinks that n is the number of iterations. Okay. Does anybody agree or disagree with Adnan? Adnan is basically saying that this is the number of steps. Okay.
Sir, Umar Ahmed here.
G.
Sir, n is basically the second number we are taking input from the user, and it's the divisor of the main numbers. And the complexity will be, I think, log.
Okay, so you've got a couple of answers. You're basically saying that the complexity will be log of n. But now you see, just because I've used parameters m and n over here, it doesn't necessarily mean that the normal n that we define is one of these parameters. Now, suppose that I had swapped these and I had called them, instead of calling them m and n, I had called them, let's say, x and y. Okay. So I could have called these number values x and y, right? So this could have been x and this could have been y. And I would have said divide x by y, right? Now there's no n defined anymore. So then when we refer to n in an algorithm, what exactly are we talking about? Any thoughts? Gzen?
The number of iterations.
So
it's the number of iterations it takes.
okay, so now let's go back a little bit. Let's take a look at this binary search. Okay. Now, what was n over here, and what did we say is the complexity? So this now should be giving you a hint.
N is the number of elements stored.
Okay, somebody's answering who didn't mention his name.
Sir, Umar Ahmed.
Okay, better. So Omar is right. Omar is basically saying that n is the, if I got you right, n is the size of the data. Okay. So now if you look at the data over here, this is a list and n was defined as the length of this list. Okay. So length of this list. So n is basically the amount of data that you're providing to the algorithm. Okay. Now, this data could be in different ways, right? In this case, the amount of data was defined as the amount of numbers inside this list, okay? And if you recall, the iterations were what? Iterations in this case was only 6, and the amount of data that you're providing was 32. So what is n over here, and what is the complexity over here? Is complexity given by n, or is it complexity given by the number of iterations?
Sir, by
the
n.
number of iterations.
So again, your names, please.
Arsalan.
Sorry?
Arsalan.
Yeah, Arsalan, go ahead.
So I was saying the number of iterations is the complexity. So
Yeah.
I guess
So it's very important to differentiate between the complexity and the amount of data you're presenting. The data could be very large, but the complexity is basically the number of iterations that you're performing. Okay. So now coming back over here, G.
Adnan.
G, Adnan.
So what's the size of data in case of Euclidean algorithm?
Okay, so that's a good question. What do you think is the size of the data? Now we only have 2 integers, okay? But do you think the algorithm will become more and more difficult as these numbers become larger and larger? So if I said find the GCD of this number, let's say, okay, this is a huge number. It's 1,001,276. And let's say the other number is 273,451. Okay, so this number is now 273,000. So do you think it's going to be easier? I mean, I gave you two examples, 8 and 12 and 8, and we could solve this problem in simply 2 steps. But do you think if you gave it a large number, the number of steps would still be the same?
Sir,
Sir,
Fawaz here.
Fawad?
Yeah, so I think that if the number is divisible, then it should take the same amount of steps.
So you're saying if the numbers are even large, the number of steps should be the same?
Yes, if we get the remainder 0 at some point.
Yeah, but do you think this algorithm will take longer to converge? If you have a very large
No.
number, it will take the same, it will still take 2 steps?
2 maybe not, but not necessarily too many.
Okay, anybody disagrees with that?
Yes, sir.
Yes, sir.
Omer?
Sir, the complexity is defined by the number of steps taken. So if the number of steps are more in this case, then the time complexity will be more.
Right. But what is the amount of data that you're giving it? What would be the n value over here?
Sir, the graph here, it depends on the difference between the numbers.
Okay, interesting point. So you're saying that if we subtract m minus n, this difference would sort of give you the complexity, the size of the problem. Okay, and that's a good thought. So if you differentiate between these two, let's say the second number is really small, the second number is, let's say, 4, then maybe this problem is not so big. Okay, so that's a good thought. Any other thoughts? How would you determine the size of this problem?
Sir,
Ji.
Tariq Iqbal, sir, I think it's possible that n will always be, that the number of iterations will always be 2. Because like I put in some values, I tested it a bit, and I mean, I obviously couldn't have tried it with such a big value as a million or something, but all the values I tried, it only required 2 iterations. So I think it might be possible that whatever m by n is, the remainder will always divide, will always be the common divisor of m and n, if that makes any sense.
Okay, I'm glad that you're trying it out. Okay, and a lot of times it's not clearly obvious what is the complexity. It's a very difficult question. And actually, in one of the courses that you'll study later on, there will be a whole course which is, or in data structures and other algorithms course, we'll actually be spending a whole course on trying to find the complexities of algorithms. Okay, so what I'm asking you is not trivial. It's a fairly complex question. Okay. But you will appreciate that once you see the answer, you might be able to appreciate, in fact, the answer is not trivial. Okay, I'm just going to tell you what the answer is, but it's not a trivial answer. Okay, somebody had a notation that it seems to be log of n. Okay, and we'll see later why perhaps this is not linear in n, and in fact the answer is log of n. But the next question again is, what is n? So n is somewhat similar to what somebody said, the difference between the two. It's not exactly the difference between the two, but the actual complexity is given by the following expression. It's the minimum of these two. Okay, so for example, if I take 1 million over here, and I take 273,000 over here, so we're going to take the minimum of these two, and the minimum in this case is 273,000. So it will be log of 273,000. The complexity, number of steps is going to be proportional to the log of 273,000. Okay, there's a question here. Is there a question? Okay, so for example, if one of these numbers is really small, suppose it's the number 4 and the other number is 1 million, then it's simply going to be taking the lower value. It's going to pick the lower of these two, A and B, and the lower number is going to be 4. And so it's going to be proportional to the log of 4, okay, which is essentially 2. Okay, you can try this out. Don't try it with numbers which is 1,273,000. Try it with slightly larger numbers. Okay, as one of you were actually trying it out, and you'll see that the number of steps is not always just 2. Okay, it's going to grow, and it's going to grow based on the smaller of these two. Okay, so if one of these numbers is much smaller than the other, then the number of steps will be proportional to the log of this. Okay, why is it the log of that? Okay, you can perhaps get an intuitive answer that because basically we're doing divisions over here. Okay, but again, this is sort of a difficult problem that I've thrown at you just to show you the deep end of the problem. And perhaps when you, at the end of this course, if you spend enough time on this, you'll be able to figure out why it's log, or you could even look at online solutions as to why this is the log of the minimum of the two. Okay, but I've just thrown this answer at you just to give you an idea. Now let's go back to something more simple. And this is a different implementation. This is an alternate implementation, which you'll also find in different places. And this says that instead of using division, which was done over here in the Brookshire and Breiler book, what they're going to do is doing a much simpler algorithm. And what it's going to do is it's going to take these two input values. Now notice they're calling it A and B. There's no N over here, M or N. They're simply taking two values A and B. And then they're saying is they're going through a series of steps, and there's looping back and forth. Okay, so now when you have an algorithm like this, the question is, how do you actually grapple it? How do you actually understand it? How do you make sense out of it? Okay, so does somebody have an idea as to, if you want to test this algorithm, whether it works or not, how would you go about testing this algorithm? How did we do it earlier? And how would you do it in this case?
Sir, by using a trace table.
Name and please reduce volume. Shayan, okay.
By using a trace table.
Okay, so this problem is not going away. Let me ask you, Shayan, why is it that you have such positive echo? Because this also creates problems in the recording. What is it that you're doing wrong, which is creating the positive feedback?
I think it's because we're all sitting in a computer lab.
Ah, okay.
Sir, why don't I just suggest, why doesn't everyone just, I'm also sitting in a computer lab, but I have both the computer open and I'm using my phone for a microphone.
Okay.
Just
so
everybody.
if anybody is sitting in the lab, then use, put on headsets, okay? Because the headsets will make sure that your audio, your speakers, if you've got speaker phones on the desktops or on your laptops, that doesn't feed into somebody else's open mic, okay, or into your own open mic.
Sir,
So next time, please make sure that you're carrying around headsets. It's fairly simple. You can see that these earphones are fairly small. You can easily carry them around. Okay. Yeah. So somebody else who wanted to suggest a solution. How would you actually go ahead and try to debug this problem, as I'm calling it? How do you actually figure out how would this problem go? And can you give me some suggestions how to go forward?
Sir, Umar Ahmed here. Sir, input two values, 2 and 1. So the algorithm will reduce it only in one step rather than in two steps. So it can be debugged after that.
So, so say that again. I didn't quite follow. How will you test this algorithm, whether it works or not?
By inputting two numbers, 2 and 1. So the algorithm will reduce it only in n is equals to one step. And after that, we.
Okay. So I think, Omar, you're suggesting that try to use a very simple number such that the algorithm actually converges in one step. Anybody else has any ideas as to how would you test this algorithm out?
Adnan.
Yeah, Adnan.
Sir, we can program this algorithm and see whether it is executable or not.
Okay, so that's a very good suggestion. Adnan is saying that let's go right ahead and jump into actually programming it. Okay. Now, a lot of people who are experienced programmers will actually do that. They will simply write an algorithm and they'll go right straight to the keyboard and they will actually start writing an algorithm. Okay. And that's perhaps one of the fastest ways to check whether the algorithm works or not. But let's say you're not an experienced programmer. How would you do that? How would you don't even know how to program yet? Okay. So how would you do it?
Sir,
Yeah.
Zarlesh.
G Zarlesh.
So we can make a trace table
Okay. So
and
would
then
that
execute the steps in the flowchart.
okay. So by trace table, are you referring to something like what I've done over here? Or something different?
Yes, sir.
Yeah, okay. So basically what Zarlish is suggesting is that let's try to do it by hand. Let's try to verify this algorithm by hand, okay? And a lot of times, even my PhD students, when they're working on a complex algorithm and they're trying to implement it, I ask them to try to look at a very trivial example, something similar to this. This is a very trivial example where you're trying to figure out whether the Euclidean algorithm will work or not, and you choose a very simple algorithm which can be tested in a few steps. Okay, so we chose two numbers, 8 and 12. I didn't pick 1 million and I didn't pick 273,000. I picked something very simple. And the reason was because I know that I can test it out in a few steps. Okay. So the way I would do it again is again, we could use the numbers 8 and 12. Okay. But this has many more steps. So how would I go about, as you're saying, Zarlish, tracing it out? How would you go about it?
सर अब्दुल्ला
Ji Abdullah.
सर ये सर हम ऑडिटोरियम में अपने क्लासेस को स्ट्रीम कर रहे हैं ना आपकी, तो इसलिए एक तो एको भी हो रही है और दूसरा अभी ये डिस्कनेक्ट भी हो गई, थोड़ा वेट करने में वापस रिकनेक्ट हो गया.
Okay. So anyway, so आपकी आवाज अभी you didn't echo, so I think you got it right.
जी सर अभी डिस्कनेक्ट हो गया ना असल में स्पीकर से, तो इसलिए आवाज एको नहीं हो रही अब.
Okay. By the way, is somebody managing the auditorium right now, or is it all of you are on your own? Is there somebody who's managing it and somebody's got a general mic? Okay. Next time, what I'm going to do is I'm going to have some of the TAs be available in the auditorium so that if you have any problems like this, they can help in resolving those. Okay. But my general suggestion is that you use headphones to be able to resolve these problems. So, so let's try to see how we could debug this or how we could sort of trace this. And the way to do it would be, if you noticed over here, I made a table, okay? And I put in values of M, N, and R. And these were the values that we were actually looking at. So what values would you select over here? So clearly, yeah.
Sir, 2 and 1, Umar here.
So what would be the headings of this table?
A/B,
right,
and then the condition loops.
Okay, very good. So what we could do is we could have the headings over here, and then it's got conditions, and we may want to see what the result is of those conditions. So we could say, is B equal to 0? Okay. So let's say we start off with the numbers 8 and 12 as before. Okay. And we could say, well, the first, we're going to input A and B, and the first condition is B equal to 0. So is B equal to 0? Clearly the answer is no. Okay. So basically what we're doing is we're going step by step through the algorithm to try to see how it actually performs. Okay. The next thing would be, is A greater than B? Okay. So we could put all of these headings in as part of the columns inside this table to be able to figure out how this is going to work. So I've got these headings done over here. And what I'm going to show over here as well is I'm going to show the number of iterations over here. Okay. And I'm also going to show the steps. So these are the steps over here, the step 1, 2, 3, and all the way up to 9. And the iterations are how many times you're going through the loop. So if you're going back in the loop, then that would be an iteration. Okay. So let's start off with iteration number 1. And let's see step number 1. Step number 1 is you input the numbers 8 and 12. And then the step number 2 would be, is b equal to 0? Okay, so is b equal to 0? Clearly the answer is no. Okay, we go down over here, and then we do this comparison. Is a greater than b? That would be step number 3. Okay, is a greater than b? The answer is clearly no. Okay, and if it's no, then we set b is equal to b minus a. Okay, so we're now going to go through step number 4. We're going to set b is equal to b minus a. So that means that 12 minus 8 is equal to 4. So that's going to be the new value of b, right? And then it's saying go back to step number 2. So now this will be our second iteration. So now we've gone back to step number to iteration number 2, and we've gone back to step number 2. Okay. So now again we're going to say is b equal to 0? Clearly b is equal to 0 is no, right? And then what I could do is I could simplify this, and I could put a whole bunch of steps in the same row. So I could say is a greater than b now? A is clearly 8 and b is 4. So the answer over here is a yes. Okay, so we're going down here. If a is greater than b, we're going to skip all the way to step number 6. Okay, so now we're going to go to step number 6. This was steps 2 to 3. And in step number 6, we're going to say a is now equal to a minus b. So a is now going to be 8 minus 4, which is now 4, right? And we are now going to go back to step number 2, and that will now be our third iteration. Okay. Now in the third iteration, we've got a as 4 and b as 4. Is that right? If I'm making a mistake, make sure you correct me. Okay. Is b equal to 0? No. Is a greater than b? Okay. No. So what am I going to do? I'm going to set b is equal to b minus a. Okay. B is now going to become, in step number 4, I'm going to set b is equal to b minus a. So now 4 minus 4 is going to be equal to 0. Okay. And then it's going to go back into the fourth iteration. All right. So now you're going back to the fourth iteration, and you can see that in the fourth iteration, I've got a is equal to 4 and b is equal to 0. Now it's saying, is b equal to 0? So the answer here is yes. If b is equal to 0, then we're going to go all the way down this step, and we're going to go to step number 8. Sorry, over here, step number 8. Okay. And we're going to say print a. Okay. So the answer is going to be number 4. Okay. So the idea here was to simply demonstrate how you can actually, as somebody had said, to actually go through this algorithm in a step-by-step manner to be able to figure out what is it actually doing. Okay. Now, there's
Abdurrahman here.
Ji Abdurrahman.
Sir, so we are sort of dry running this algorithm.
Yes, yes, that's a good way to put it. So this is sort of a dry run of this algorithm. Okay, there are different ways in which you can describe what I just did. You could call it a dry run. You could say that I'm manually testing this algorithm out with a simple example. And by manually testing it out, you get a good feel of what the algorithm is doing. Okay, and you can also debug this. So if, for example, if this algorithm somehow doesn't give you the right answer, you can actually figure out where is it going wrong. Okay, so it's always important that whenever you try to implement an algorithm, you might have an idea in your head, but it's always important to be able to test it out in a simple step-by-step manner to make sure that it's giving you the right results. Okay, so it's giving us the number 4 over here. We already know that the answer of 8 and 12, the GCD of 8 and 12 is 4. Okay. Now, if you want to do a more complicated example, you could pick another couple of integers and try to see if it actually works or not. Okay. But this is a very important step whenever you're writing complex algorithms. And this is where a lot of people get confused as to how do I write a complicated algorithm. So the first thing that I would suggest is try to implement it by hand. Okay, try to think at a high level, how would the algorithm actually work? And once you've got a rough idea as to how it would work, you can actually put it into a flow diagram, test it out, and once you've tested it out, then you can actually go and write a Python or Java program and try to implement it. And let's say you implement it. Okay, after you implement it, you get the wrong result. Now, where could the problem be? So let's say you implemented the high level the algorithm was working fine, but now the result is not coming out. So what do we do now? Any thoughts?
Adnan.
Muhammad Bilal.
Adnan, go ahead.
Obviously, I think the problem would be in the program.
Yeah, yeah. So your algorithm is right. In other words, this flow diagram is basically the algorithm. Okay, this is correct. However, when you've implemented in Python, there could be a million problems. It could be initially, it may not even run. It might give you an error, in which case there's a syntax error. As you saw in the Python program, you might have syntax errors. Now, if there's no syntax error and it runs, but it's giving you the wrong answer. Now, if it's giving you the wrong answer, how do you actually debug it? How would you figure out what's the problem? Any thoughts on that? So the problem is with the program, but you're trying to now figure out what the actual problem is.
Sir, Yumna Masood.
Ji, Yumna.
Sir, the IDE, it's probably going to alarm us, like highlight the area of problem, which will help us get it better.
Okay, so as you mentioned, the IDE will definitely help you. If you have a good IDE, a good development framework, then it's going to definitely help you. Okay, we'll talk about that more when I actually demonstrate this on the Python programs. But a lot of simple ways to do it is that in every step, as you're going through this iterative program, you do print statements. Okay, and in every step, you actually print what is the value. So as you're going over here, and as B is changing, for example, B is set equal to B minus A. So you simply have a print statement and you say print B, okay? So that will allow you to step by step go through the program and to be able to figure out what's going on inside the program, okay? Now, good development frameworks will actually allow you to go inside the program and step by step go through and look at the variables, okay? And we'll hopefully get a chance to do that as well. So this is just the nice version of that same program, and you can look at it later on as well. But basically, I've given you an idea as to how to actually go through and step by step debug this program, okay, and to verify whether the program is working or not. So this was the first algorithm. G. Question?
Umar Tariq. Sir,
Umar.
if there were prime numbers, what happens?
So I didn't quite get your question. Too much background noise. What was your question again?
If there would be two prime numbers.
Ooh, that's a very tough question. So what you're saying is that what happens if the GCD comes off as two prime numbers? The mathematicians over here, tell me what the answer would be. And how long would it take?
Muhammad Bilal.
Ji Bilal.
I think the answer would be 1.
So the GCD would be, yes, I guess it would be 1. Okay, because if you have two prime numbers, for example, if you have 5 and 7, then clearly the largest integer would actually be 1. Okay, because 1 is the only integer which can divide the two. But how many steps would it take to actually find this out?
Sir, Umar here, it will be an infinite loop.
It would be an infinite loop. So the problem over here is that it is assuming that an answer exists. Okay, so so you'd have to look at this and see whether it's got a proper terminating condition, and this particular algorithm may not be properly designed, okay, to handle prime numbers. So you'd have to see whether it's going to result in an infinite loop or it's actually going to work properly. Okay, so these are the things that that's a very good question to see whether what happens in extreme cases, and will this algorithm work or not. Okay, so you can test it out and see what actually happens in this algorithm. I'm not going to give you an answer right now, but you can test it out. All right. So let's move on. Now, I'm going to now take a different step, and I'm going to now look at implementations in Python of some of the algorithms that we've already looked at. Now, the last homework assignment, hopefully, I think most of you, the majority of you have actually submitted the homework assignments. You've actually getting a hang of Jupyter, and you're trying to implement it now. So hopefully, you are getting your hands wet with Python. So now my question to all of you now is, how would you actually implement this algorithm? Okay, so this was the first example, 1A, where we simply had a list, okay, and we wanted to see if we can implement it. So this was a high-level flow diagram. Now, how would one, from whatever you know of Python programming, how would you actually implement this?
Sir, Sir, by using the for loop, for next loop to implement the I condition and increment the I value one by one, and using the length function to determine the length of the total data in the array first, and then after.
Okay, very good. So you basically got the idea. So you'd start off perhaps by 0, and you might go up to, because basically what you're trying to do is you're trying to step by step go through this list, okay? And you want to have a terminating condition which says that if I becomes greater than, then you want to. Now, we already know that if you use the range command, okay, range function, then it will go through all of these values for I is equal to 0, and then 1, and then 2. Now, should it be from I is equal to 0 to n, or should it be n minus 1 or n plus 1? What should it be over here?
So it should be 0 to n.
So if you do using the range function, what should it be over here? Remember, the range stops at n minus 1. So if you want to go from 0 to, let's say, 5, that would be 0, 1, 2, 3, 4. So 0 to n would be okay, actually. Okay. So you would do that, and then you would do the comparison and have a result. Now, let's say you find, how would you do the comparison? You simply have the statement, if list sub I is equal to x, how would you go in one direction versus the other direction? Okay, how would you implement this?
By using the if then else loop, then else condition.
So you have an if condition. So let's say if list sub I is equal to x, then what would you do?
So print I and result is equal to.
So you would say print I, and then, but this loop is going to keep on going. Is that okay?
No, sir, then
break statement.
else condition.
Okay, good. So you've got an idea of how Python works. So let's take a look at this algorithm. And this is a sample for those of you who are not familiar with what was just said, break statement. So whenever you start off writing an algorithm, it's always a good idea to break it up. Okay, so the first thing that you should do is try to initialize. Okay, so now you see that in the initialization, I haven't specified all the details, but what would you have in the initialization? Clearly, you must have the list. Okay, you have to actually enter all the actual data that you want. Then you also want to have an n value, and then you've also got to have an x value. So clearly, all of these parameters have to be as part of the initialization. Okay, so this is the initialization where I've already got all of these parameters, these variables as they're called. These variables are set up. Okay, now the next thing that is always a good idea is to actually print these values out, because when the results come out, it's always good to know what was the actual list. Okay, what was the number that you were searching for? So it's a good idea to actually print the list, the variables that you're looking at, the n value, and the value that you're searching for. Okay. Now I'm going to use a variable, and this is called a Boolean variable. Okay. Now, there are different types of variables that we'll look at later on, but there can be integers. Okay. Integers basically have the values 0, 1, 2, 3, and so on. Obviously, it could also be -1 and so on. All right. G, question.
Let me ask a question. So why can't we use the while loop when we're already while we're initializing a Boolean variable?
Okay. So we could use, there could be many implementations of this. Okay. And what is being proposed over here is something called a while loop. Now, we haven't studied that as yet, so I'm not going to use that. We're only using a for loop so far. So let's stick with something that we're already familiar with. And you could implement this with a while loop as well. Okay. And there are different things. You could have a do loop and so on. So let's not look at this. So in this, basically what we're doing is now we're using a Boolean variable. The found is being set now in Python. You can simply determine whether a variable is an integer or a Boolean by how you're initializing it. Okay, I mentioned this earlier as well. So for example, if you set x is equal to 3, is going to, Python is going to be smart enough and it's going to say, well, 3 is an integer, so I'm going to set x to be an integer. Okay, so x will in the future, all the values of x are expected to be integers. Now found is being set to false. Okay, now this is, if you notice, this is in bold. Okay, now if I switch to the Python, let's see if I've got it running over here. Okay, so let's, I hope everybody can see my my screen, which is showing the Jupyter screen. Is that visible to everybody? Yes?
Yes, sir.
Okay. So as you can see that I'm running this initialization. If I run this, it's simply going to print all the values of I in this range from 0 to n. So it's going from 0 to 4 and it's printing out the values of list I. Okay, so these are the elements of I, of the list. So 10, 3, 5, 20, and 6. Next, what I've got is this algorithm. And let's say if I run this, you should be able to see the results. So let's take a look at what it's supposed to be doing. So it's going to print these values. So if I set found is equal to 2, then this is going to become an integer. Okay. If I set, instead of 2, if I'm setting it to be false, then false is a special term. Okay. It's a reserved word. And as soon as I type in false, you notice it becomes bold. Okay. So this means that it's going to have only true and false values. If I type true over here, and this is, by the way, case sensitive. So if I type true over here, it's actually not going to understand it. Okay. But if I type true with an uppercase, it's going to convert into bold and it's going to become a Boolean variable. So Boolean basically means that it can have one of two values. It can either be true or false. Okay, so I'm going to be setting this to be
Sir Fawaz here.
G Fawaz.
Yeah, so I want to ask, how does the len function work? Does it come from 0 or 1? So for example, when we're using it over here, when for the range, we're not putting n minus 1, but only n.
Yeah. So remember the range function, which we've already discussed earlier, goes from 0 to n minus 1. Okay, that's how range is defined. So if you say 0 to 10, it's going to go to 0 to 9. Okay, so we've already covered this earlier. All right. So now you've seen that I'm using a special variable, which is a Boolean variable, and there's a reason for that. And as you can see, as we go forward, initially I'm going to start by printing all the values from here, list to up till here. It's actually printing out the initial variables. And now it's starting the iterative algorithm, and I'm printing starting iterative algorithm, so you can see exactly where the algorithm is actually starting. Okay. I noticed that there is some background noise. Does somebody have their mics turned on? Can people make sure that their mics are turned off all the time? So I'm going to try to mute everyone. I'm just trying to figure out how to do that. Okay, anyway, the sound is gone. Okay, thanks. So basically, if you come back over here, you'll notice that we are now going to go through this loop. We're going to print the value of I, okay? And now when we find the value that we're looking for, I'm going to say print and the value of I, but I'm also going to set this variable to be true, okay? And the reason why I'm setting this variable to be true is to make sure that we know that we found the result, okay? So if we go back to our algorithm, somehow we've got to be able to say that when we find this result, we've got to know that we've actually found this result. And how do we do that? We've inside the if condition, I've actually set this variable, the Boolean variable, to be true over here. Okay. Now this loop is going to keep on going all the way till the end. And at the end, it's going to print a true. So as you see, it went through I is equal to 0, 1, and at I is equal to 1, it found the value because I had set the value of x is equal to 3 and x is equal to 3 is found in the first index, and it got the result as true. Now, my question here is this a good algorithm or not? And
no, sir.
Yes, Saad, why is this not a good algorithm?
Sir, because once it finds the value, it still continues finding it.
Yes. So clearly, this is not a good algorithm. How many steps is this going to take? And what is the average number of steps it's going to take? What's the minimum number of steps? What's the average number of steps? And what's the maximum number of steps? Okay. So every time you write an algorithm, think about the minimum number of iterations, the average, and the maximum. Okay. So minimum, average, and maximum.
They're all going to be the same.
They're all going to be the same. They're all going to be actually n, right? Because even when you're finding it in the first position, this for I is equal to 0 to n is going to keep on repeating till you get to the value of n. So even though you found it at, let's say, in the first position, this is not going to stop. It's going to continue doing it. Okay. So somebody had mentioned a term called break. Okay. And the break command, what it does is it allows you to actually break a for loop. Okay. So what you can do is in the next example, so if I, for example, over here, you can see it's going from 0 to 4. Now, instead of having just found over here, if I set a break command, and as you notice that as soon as I type break, it becomes bold because that's a special command. And now if I run it, let's see what happens. It goes from I is equal to 0, I is equal to 1, and then it says it's found, and then it doesn't go through the rest of the values. It doesn't go to 3 and 4, okay? Simply because break is going to break it out of the if loop. Sorry, it's going to break it out of the for loop, okay? So, so that was a simple example of an implementation of the first algorithm that we saw. This is a simple example of the second algorithm that we saw, the 1B, which was the reverse condition. And now all we've done is we've started with, and we've already studied this, you can have range in which you're actually decrementing. So you're going from n minus 1, you're going all the way up to -1, and you're going to decrement by -1. Okay, so this should be fairly straightforward. So any questions up till this stage? Okay, if not, let's go on. Okay. The next thing that we're going to look at is something called functions. Okay. Now, a lot of times you may have a part of the code which needs to be repeated over and over again. Okay. For example, if you're trying to calculate, in this particular example, is simply trying to calculate you have a value 2, and you're simply trying to calculate 2x. For example, can people please keep their mics off? Manahil, you had turned your mic on. Please make sure that you don't have your mic on unless you want to ask a question. So suppose that you're trying to calculate 2x. It's a very simple example. Or suppose you're trying to calculate the equation x squared plus y. Okay. So what you can do is you can simply write a function so that every time you can, you don't have to repeat the code. So the way you write a function in Python is fairly straightforward. You say df, which is special terms, and you give a name of the function, and this is an argument. So here I'm simply giving it a single argument. In this case, I'm giving it 2 arguments, x and y. Okay, and it's simply going to return the number 2 times x. Okay, so when I call this function print fun1, and I've called this function fun1. So when I give it the value 3, what's going to happen is that x is going to be assigned the value 3, okay? And then it's going to calculate 2 times x, and it's going to return that, okay? And then eventually it's going to print that result, okay? So fairly straightforward. If you have 2 arguments, x and y, then you need to provide, for example, when you call it, you need to provide 2 variables. And let's say you provide 3 and 1. So what you'll get is x will be assigned the value of 3, y will be assigned the value of 1 over here, and it's simply going to calculate this expression, which is x squared. This is how you write x to the power of 2. So in some languages you use x to the power of 2 like that. In Python you actually use 2 asterisks, and that simply means x squared. It's going to calculate this expression and it's going to return it as part of this. So this is going to return the number 3 squared plus y plus 1, which is 10. And then this in turn is going to print the number 10. Okay. So far, I hope that's clear. We can simply look at this. And this is, if we run this function, you can see that it returns 6 over here. If you run this function, you can see that it returns 10. Okay. Any questions about these 2 functions? So no questions. So that's fairly simple definitions of functions in Python. Now let's take a look at a simple iterative algorithm. Okay, an iterative algorithm is something which simply is something similar to what we've already seen. It goes from I is equal to 1 to n, for example. That's called iteration. Okay, so can somebody tell me how would you actually implement factorial of n? Now, people, I hope you remember what factorial is, and you do. It's also written as n factorial like this. So that's simply n times n minus 1 times n minus 2 all the way till 3 to 1. Okay, so for example, if I write 4 factorial, it's going to be 4 times 3 times 2 times 1. So any thoughts about how one would actually implement the factorial algorithm?
Adnan.
Ji, Adnan.
So there's a way called recursive function. We can use the same function inside.
Okay.
So same functions.
Okay, but what I'm going to ask you right now is not a recursive function. We'll get to that later. But let's say I'm asking you how to implement an iterative function. Okay, and an iteration is a very simple way. Now, what Adnan had mentioned is recursion, which we're going to get to probably in the next lecture. Recursion is an algorithm which calls itself. Okay, and it's sort of counterintuitive. How would a function which calls itself actually make sense? Okay, that's all. So you're sort of defining something it's sort of defining, you're defining it by its own self. And that doesn't make a lot of intuitive sense. But we'll get to that later. So let's look at a simple iterative algorithm and how would you actually implement n factorial? So any other suggestions?
Sir, Umar Ahmed here.
Umar.
Sir, we will be defining first like factorial function and result is equals to 1. And after that, we will be using for next loop for I in range and 2 comma n plus 1.
For I in range, let's say 2 comma
n plus 1.
Okay. Okay.
And then result is equals to I.
Okay. So result is equal to I. So you've got a fairly good idea. If you look at what I've shown you over here, is somewhat fairly similar to what you've actually done. Okay. So I've defined a factorial, a fact iteration. Okay. So as opposed to fact recursive, which I'll show you next time. So in this case, basically, I've given you a variable n. And what I'm doing is now I'm starting with a result f is equal to 1. So f is going to be the result of this. Okay, so I'm going to at the end return f. And what I'm doing is I'm saying for I in range 2 to n plus 1, and why have I picked 2 and why n plus 1, you can figure these out as well on your own. Okay, so what I'm doing now is I'm saying that, for example, when I want to calculate 4 factorial, so what I need to do is 4 times 3 times 2 times 1. So I'm going to start with I is equal to 1. Okay, I could have, let's say, picked, instead of 2, I could have picked 1. Okay, and then I need to have the result, and then I'm going to do 2 times 1. I'm going to increment I to 2, and I need to put in the result somewhere. So I'm going to put the result into f. Okay, so basically what I'm saying is f is going to be the previous result, which was previously was f, and I'm going to multiply it with I. Okay, and I'm going to keep on incrementing I. So initially what happens is that when I say factorial iteration 4, so initially n is going to become 4. Okay, so again, if you want to debug this, you want to figure out whether it's going to give you the right result or not, how would you do it? You would go back to the basic example that I gave you earlier, start with making a table and trying to put down the values. Okay, so you could say n over here, and you would put down the value of f, and you could put down the value of I. Okay, so this is how you'd start it off. You would say n for f is equal to 1. I is going to be initially over here 2. Okay, and you're going to set f is equal to f times I. So f is now going to become I 1 times 2, which is going to become 2. Okay. Similarly, if you keep going forward, now I is going to become equal to 3, right? And f is now going to become f times I, so it's going to become 2 times I, which is now 3. So this is going to become 6, okay? And now I is going to become 4, and so it's going to become 6 times 4, and that's going to be 24. Okay, so you can see that if you don't understand what this algorithm is doing, the basic way is to make a table, put down the values of the variables, and try to see whether it's giving you the right result.